So hey guys, welcome to lecture number 2, and lecture number 2 is of aldehyde and ketone, and in lecture number 2 we are going to cover up the method of preparation of aldehyde and ketones, right? So basically I divided this lecture into 3 parts. First part is we are going to discuss those methods by which you can prepare aldehyde as well as ketone, and in the second method we are going to discuss those methods in which you can only prepare aldehydes, and the third method, that is only specifically or exclusive method for the ketones only. So the first method that I am going to discuss here is method of preparation for aldehyde and ketones. So the first method that I am taking is oxidation of alcohol, right? So let me tell you about oxidation of alcohol. So suppose if you have 1 degree alcohol, okay, what is the meaning of 1 degree alcohol? 1 degree alcohol means CH3CH2OH. Okay, here OH is attached to this carbon, and this carbon is only attached to one carbon, so that is 1 degree alcohol, right? So guys, if you will do its oxidation, like suppose oxidation, nascent oxidant, okay, oxidation, right? So it will convert first into aldehyde. It will convert first into aldehyde, okay, but aldehyde will not stop here. It will convert itself into acid. 1 degree alcohol, first it will convert to aldehyde, then it will convert to acid, right? So alcohol will directly change into acid if you are doing the strong oxidizing agent, and we don't want acid, we want aldehyde. So it means we have to use mild oxidizing agent. What kind of oxidizing agent we have to use? We have to use mild oxidizing agent. If you want this only, that it will convert into aldehyde. Okay, so what we need? We need mild oxidizing agent. We need mild oxidizing agent, right? But if you want to convert alcohol directly to acid, okay, so what we need? We need strong oxidizing. We need strong oxidizing agent. Okay, directly to acid, so we need strong oxidizing agent. Okay, not a problem, right? So right now though I'm discussing about method of preparation of aldehyde. So yes, so we need mild oxidizing agent. So let me give you the list of mild oxidizing agent that we will use. So one is PCC, pyridinium chlorochromate. Okay, PCC, but maximum time they will write in this form only, PCC, pyridinium chlorochromate. I'm not writing the name, okay, PCC. Then we have PDC, pyridinium dichromate. Pyridinium dichromate, okay, this is pyridinium chlorochromate and this is pyridinium dichromate, right? And then we have CrO3 in anhydrous medium, CrO3 in anhydrous medium, okay, chromium trioxide in anhydrous medium. So they all act as mild oxidizing agent. Okay, we have more reagent also. Saret reagent is there, Collins reagent is there, but that is not given in NCERT. So whatever given in NCERT, I'm only telling you those, right? So one is given PCC, PDC and CrO3 anhydrous medium, right? So they are mild oxidizing agent. Now let me give you the list of strong oxidizing agent also. So strong oxidizing agent is your favorite alkaline KMnO4, alkaline potassium permanganate, and second one is guys acidified. Second one is acidified K2Cr2O7 potassium dichromate, and the third one is chromium trioxide in H2SO4. Chromium trioxide in H2SO4. So when they will write these oxidizing agent, then they are strong oxidizing agent. And what basically strong oxidizing agent do? They convert alcohol directly to acid. But pay attention, I will discuss a few more important points, right? So regarding oxidation of alcohol, you should know this. If it is 1 degree alcohol, ROH means alcohol, 1 degree, right? So if you will do its reaction with PCC, then you will get aldehyde. Okay, if it is 2 degree alcohol, and if you do its reaction with PCC, then you will get ketone. Okay, but let me tell you very important point. 3 degree alcohol does not undergo oxidation. 3 degree alcohol does not undergo oxidation, right? So by doing this, we can convert alcohol to we can convert alcohol to carbonyl compound. So 1 degree with mild oxidizing agent to gives you aldehyde. But suppose if I will use K2Cr2O7, then alcohol will directly convert to acid. So 2 degree gives to ketone, right? And 3 degree does not undergo what oxidation. Okay. So one more important point I would like to tell you here, that even if I use for 2 degree alcohol, even if I use alkaline KMnO4 or acidified K2Cr2O7 or CrO3 in H2SO4, right? So still I will get ketone. Now you are in the doubt, but sir, ketone will further oxidize to acid. Yes, we can oxidize ketone further to acid, but the thing is that the oxidation of ketone is not that easy. For aldehyde, we can easily convert them into acids. But ketones oxidation is not that easy. It required elevated temperature and elevated pressure. In the presence of strong oxidizing agent, we need elevated temperature and elevated pressure. Then you can do the oxidation of ketone. Otherwise you can't. Right? So even if I write strong oxidizing agent here, so still you have to write for 2 degree. You have to write a ketone only, until and unless it's not mentioned that high temperature and high pressure, then we will only stop here only, right? Ketone, right? So many students are thinking, okay sir, it's clear, 1 degree alcohol will give you aldehyde, 2 degree gives you ketone, and 3 degree will not oxidize. But what is the reason that why 3 degree is not undergoing oxidation reaction? So we are also going to see the reason. So first of all, I'm giving you some questions and I want answers from you, right? So suppose these type of questions are writing. First, very easy question, right? CS3 CH2 OH. Okay, so suppose I'm doing its reaction with PCC. Second, cyclohexanol. I'm doing its reaction with PCC. I want products from you. Question number third is, guys, CS3 CH CS3 CH double bond CH2 alkene. First I am doing its reaction with dilute H2SO4, that is my A product, and then I am doing its reaction with PCC, that is my B product. You have to tell me what is A and what is B product. Okay, so not a problem sir. Alcohol and PCC, oxidizing agent, what happens? Same carbon aldehyde. That's it. This group CH2OH will change into what? CHO. That's it. That will happen in aldehyde oxidation. Right guys? What about PCC? Check the degree. It's to 2 degree. 2 degree will change into ketone. What ketone you are expecting? This ketone. Understood? This is my first question. This is my second question. Now what about my third question? So see, what is third question? So third question is, I am mixing the questions now. This is alkene, this is dilute H2SO4. So if you remember, then I told you in alcohol and phenol chapter that alkene and dilute H2SO4, what we do basically, we do hydration, and this is hydration. We do add H plus and OH minus according to what rule? According to Markovnikov rule. Add H plus and OH according to Markovnikov rule, right? Mechanism, even I told you that hydration mechanism is important for your CBSE exams, right? In first step, attack of electrophile. Second step, formation of carbocation. Third step, deprotonation. Okay, no, first step, attack of electrophile. Second step, attack of nucleophile, water. Then formation of cation, carbocation, and then what? Deprotonation, you will get alcohol, right? So here, what is the Markovnikov rule? Negative part of the reagent attack on that unsaturated carbon, double bonded carbon, which contain negative part of the carbon attached, negative part of the reagent attack on that carbon which contain less number of hydrogen. So this, right? So what I will get here? I will get CS3, CHOH, and CS3, right guys? What is the degree? 2 degree. So 2 degree then further convert into ketone. Done? Okay, so this is your third question. Okay, so I think now you can do the oxidation of alcohol questions very easily. This is how we do the oxidation. Many times they will ask PCC, but even if these reagents are also given PDC, CrO3 and anhydrous medium, then yes, we can do that, right? Now, strong oxidizing agent. So 1 degree will convert to acid directly. So that we will discuss in method of preparation of acids. You can prepare acid like that. Understood? Okay. So one thing that is left, then why 3 degree alcohol does not undergo oxidation. So what is the reason for that? Okay, so we are going to discuss that reason. Sorry. Okay, so what is that reason? Let's discuss. So guys, in 3 degree alcohol we have CH3, CH3 and OH. Okay, CH3, OH, right? So in case of 3 degree alcohol, this is your functional group. Okay, and carbon corresponding to functional group, this carbon. What is this carbon? This carbon is alpha carbon. Okay, so let me tell you what is oxidation basically. So basically guys, oxidation is loss of hydrogen, right? So if you will see the mechanism is not a part of our syllabus, but if you will see the mechanism of this reaction, so in mechanism, basically the alpha hydrogen of carbon will release, alpha hydrogen of carbon will go out. But still here, this is alpha carbon. Is there any hydrogen with this alpha carbon? Okay, no alpha hydrogen. So that's why its oxidation is not possible. No alpha hydrogen is present. No alpha hydrogen is present. Therefore, no alpha hydrogen is present. Therefore, its oxidation is not possible. Therefore, its oxidation is not possible. Understood? Clear? Okay. So this is how we will write the oxidation product. I hope now you can discuss. You can basically write the answers. They are very easy answers, right? Whatever the fundas I am telling you, just do those fundas to write the answers. Okay, guys. So this is your oxidation. This is your oxidation of alcohol. First method of preparation, oxidation of alcohol. Right, guys? Okay. Now after this, so we can prepare both aldehyde. We can prepare both aldehyde and ketone. Right? Second method is by dehydrogenation of alcohols. By dehydrogenation of alcohols. By dehydrogenation of alcohols. Okay, so by dehydrogenation of alcohols, right? So how we will do that? Okay, so basically, if you have 1 degree alcohol, if you will pass the vapors of 1 degree alcohol through heavy metals like copper sulfate, and temperature is 573 Kelvin, then 1 degree alcohol gives you aldehyde. Okay, and if you have 2 degree alcohol, if you will pass its vapor through copper at 573 Kelvin, then you will get what? You will get ketone. And if you have 3 degree alcohol, and if you pass the vapors of 3 degree alcohol, then you will get, guys, alkene. Okay, so this reaction, as it is, you have to remember. Okay, dehydrogenation of alcohol. Questions are so very easy. Okay, right? Okay, का question अपन कर भी लेते हैं, right? 3 degree alcohol. So suppose if I am asking you CH3, CH2, OH, 5 copper solid, 573 Kelvin, complete. Okay, question number 1. Question number 2 is copper solid and 573 Kelvin. Copper solid and 573 Kelvin. Question number 2. Question number 3. Okay, this is the question number 3. So what happens in first step? 1 degree dehydrogenation, alcohol से क्या बनेगा अपने पास? Acid और aldehyde. Okay, 2 degree what will form? Ketone. Okay, 3 degree gives you alkene. So basically this is basically elimination reaction. Okay, what kind of elimination? Beta elimination. Remember that alcoholic KOH, that kind of reaction, beta elimination. Okay, so from alpha we will remove OH, and from beta, this is beta 1, this is beta 2, this is beta 3 beta, you remove hydrogen. So since all beta is same, so from any beta you can remove hydrogen. So suppose I am removing hydrogen from this beta, so we will get this kind of product, and this is your, what is your alkene. Okay, so this is your by doing dehydrogenation. This is by doing dehydrogenation of alcohol. Understood? Clear? Okay, so this is your second method, right guys? Now, what is your third method? Third method is, so from alcohol we discussed, two methods from alcohol we discussed. For what? First one is oxidation of alcohol and second one is dehydrogenation of alcohol. Third method is from hydrocarbons. Okay, so A is ozonolysis of alkene. Very easy, huh? Ozonolysis of alkene. Okay, so what is ozonolysis of alkene? So start with the example, CH3 CH double bond CH2. So what we do in first step, we do its reaction with ozone. I will tell you the trick also. First of all, I am telling the basic method, ozone. So in first step, what happens? This kind of hot type of structure will form, ozonoid. Okay, and what we call this? We call this ozonide. Okay, in second step, we do its reductive ozonolysis, ZnH2O, zinc H2O. Okay, what happens? Then we will break like this, cleavage, and what we will get? Tell me, CH3 CHO. Well, yes, CH3 CHO plus yes HCHO plus HCHO, acetaldehyde plus formaldehyde. Understood? Yes, you obtain what? Aldehydes. You obtain what? Aldehydes. Understood? Similarly, okay, or like trick wise, so you can solve like this. Basically, break this bond, double bond. Put O, put O. What is the answer? CH3 CHO, HCHO. CH3 CHO, HCHO. Understood? Second is, let's say ketone का ले लेते हैं कुछ अपन. CH3 CH3 double bond CH2. Okay, and I'm doing it step 1 ozonolysis. Okay, like this, O3, and second step ZnH2. Now you have to write the direct answer. So yes, you can make a heart also. But yes, I told you the trick. Break double bond. Break it. Put O here. Put O here. So this will be CH3 CH3 double bond O. Because bond between carbon and oxygen is to double, right? And what it will be? CHH, and this will be double bond O. So what is this? This is the HCHO, formaldehyde. What is this? This is acetone. So you got what? You get what? You got ketone as well as aldehyde also. Clear? Understood? Clear? So question number 3, last question for you. Okay. So suppose we have cyclic type of structures. Usually students are confused in this kind of questions, so that's why I'm doing it, right? So if I'm doing its reaction with O3, and in second step I'm doing its reaction with H2O. O3 in second step ZnH2O. This is basically known as in reductive ozonolysis. Okay, ZnH2O is known as basically reductive ozonolysis. And yes, in NCERT only reductive is given. It is also can be oxidative. If you will not use zinc, then it can also be oxidative, but that we are not going to discuss, right? So what will happen? This is double bond, break it. Put O, put O. Okay, now take, start here. CH3, C. So this carbon is attached to a double bond. So I'm attaching a double bond. So in order to fill valency, 1H. Okay, right? Then now this carbon is attached to a double bond and this. So So, or I can also write how many carbon atom? 1, 2, 3, 4, 5. 5 carbon atom like this. CHO, CH2, CH2, CH, CH3 and CHO. Okay, this is your structure. This is the answer. And if someone asks you to name it, then what will be the name? 1, 2, 3, 4 and 5. What will be the name? 2-methyl, yes. Pentane, 1,5 diol. Right? So name will be 2-methyl pentane 1,5 diol. Pentane 2-methyl pentane 1,5 diol. Understood? Clear? So tell me, can you do the ozonolysis type of questions? Okay, so trick, I told you, remove double bond and put O plus O. O. Right? Very easy questions, yeah. क्या ये कुछ भी नहीं है, right? So this is your ozonolysis. Understood? Okay, so this first method is by ozonolysis of alkene. Now, the second method. So I'm rubbing it off little fast. So you can pause the video if you are taking the notes. Okay, that is the advantage of video. You are controlling me, right? Okay, so second method from hydrocarbon is important. Okay, hydration of alkene. Hydration of alkyne, sorry. Alkene से तो alcohol बनता है, right? Hydration of alkynes. Hydration of alkynes. Okay, so this is important. Suppose we have alkyne like this, CH3 C triple bond CH. So basically, yes, you can use dilute H2SO4, that is your hydration agent, or I have seen that we can also write Hg2 plus water. These are both hydration agent, right? What you have to do, basically, first to add H plus OH according to Marconic rule. Add H plus OH according to Marconic rule. तो करो, negative part, positive part where more hydrogen, negative part where less hydrogen. Okay, so yes, that will answer CH3C OH. Single bond will change into double bond because you are adding 1 mole, right? So 1 mole, then we will get what? CH2. Okay, so basically guys, this form is known as enol form. Okay, there is one kind of isomerism that we have learned in 11th standard, tautomerism. So this is known as enol form. Okay, like you can give like this one number like 1, 2, 3. So enol form more stable. They are in dynamic equilibrium. Enol form will change into keto form, and that is more stable. So when you are going to write the final product of this question, so we will always write the keto form. How to write the keto form? Basically, so what do you do from first oxygen, take the hydrogen and take the hydrogen and put it on the third carbon and shift the bond between 2 and 3 in between 1 and 2. Let me write CH3 double bond. Right? This H will go here and this double bond shift here. Clear hai? Okay, you can do it like this also. Okay, this H will go so here. Minus charge plus minus will form a bond and CH3. What I will get? In the end, I will get acetone, ketone. Clear hai? Right guys? So it is important, okay? So yes, enol form will change into keto form. What you have to do in keto form? Enol form 1, 2, 3. H of oxygen will go to third carbon and the bond between 2 and 3 will become in between 1 and 2. That is your keto form. Right guys? Okay? So this is also a good question, right? Like many students can't solve this. Then we have, suppose CH triple bond CH. Again, I'm asking you complete it. Sometimes they will only write Hg2 plus, mercury 2 plus. Again hydration. So karo. So we have CH2 double bond CH OH. Yes. 1, 2, 3. So oxygen hydrogen will go to third CH3. This bond will become single and it will become double. Right? So what is the answer? What is the answer? CH3CHO. CH3CHO. What is answer? Aldehyde, or I will say common name is acetaldehyde. Common name is acetaldehyde. This is your enol form. This is your enol form, and this is what? This is your keto form. This is your enol form, and this is what? This is your keto form. Understood? Okay. So even I can tell you the trick also. Okay. So even that is okay, but okay, I think there is no need. You just solve hydration of alkene like this. First you write the enol form, and then you write keto form. Okay. So trick is also there. If you want me to tell you the trick, then I will tell you the trick also. Okay. But the trick will always give you the final answer. CH3 C triple bond CH. Suppose if we are doing its reaction with dilute H2SO4. So basically we have to add H plus comma OH minus, which rule? According to Markovnikov rule. That is what we have to do. Add H plus and OH minus according to Markovnikov rule. Now the thing is, listen, the important point here is that whenever alkene reacts with whenever you are doing the hydration of alkene, we always add 1 mole of hydrogen. But alkyne need 2 moles. So alkyne need 2 moles. So we will add 2H plus and 2 OH minus. We will add 2H plus and 2 OH minus according to Markovnikov rule. Direct add kar do. So we will have negative part. So 2 OH over here and 2 hydrogen over here. Right? Now if you guys know, then 2 OH group on a carbon, on a single carbon is not stable due to hindrance. Okay? So water will release. So like this. Minus H2. So if water will release, what is the answer? CH3, COO, CH3. What is the answer? Answer is acetone. Are you getting my point? Okay. So yes, you can use this trick also. Add 2 moles. Okay, here I'm writing. Add 2 moles of H plus and OH minus according to Markovnikov rule. Okay, but sometimes your school teachers are expecting you to write this answer. So I will suggest you can follow this approach also, right? Okay, this is the trick part. Done. Okay, so this is how by doing hydration of alkene. By doing hydration of alkyne, we can get the aldehydes, we can get the aldehydes and ketones. Understood? So this is your method of preparation of aldehydes and ketone, right? So this is it for today's lecture, and in next lecture we will see method of preparation of aldehydes only and ketone only. Done? Thank you.